Hey guys, so last time we looked at this generalized overview on how to draw structures, and pretty much we just looked at the common organic elements and just saw like the ways they bonded, or like the number of bonds they typically have. And so that's what we did there, and then we went into a little bit into what units of unsaturation were and how to identify them, I guess. And we came to this conclusion that double bonds and rings are each 1 unit of unsaturation, and triple bonds are 2 units. And remember, a unit of unsaturation means that your structure is lacking in 2 hydrogens. And I'm going to show a little bit of what that actually means. So last time I drew this guy, and I drew his relative, I guess. And so how do we go from the structure on the left, the fully saturated structure, to the one on the right? Well, let's take away this hydrogen, and then let's also take away this hydrogen plus that bond. And remember, a bond is 2 electrons. So what we're doing is we're taking away 2 hydrogen atoms without the electrons, and then we're also taking 2 electrons. And then if we just shift those 2 electrons here, we get the structure shown on the right. So pretty much we're losing 2 hydrogen atoms, and that arrow means that we lose 2 hydrogen atoms, each with 1 electron. And so that was for our double bond. Let's see what that looks like for a ring. So this is our straight chain carbon. I just drew it a little differently so that it could show the transformation more readily. Oops. And it's pretty much the same thing. We can take away 1 hydrogen without its electron, and then 1 hydrogen with 2 electrons, and then we can make this shift again from this carbon here to that carbon and form this bond between those 2 carbons, and we end up with this new structure with the ring. And I'm not going to go into detail on how to make the triple bond. You pretty much do the same thing, but this is how to create your unit of unsaturation. And now that we've defined what a unit of unsaturation is, let's figure out a way to determine its presence in structures based on the chemical formula. So let me clear some space. I'm just going to draw this structure. And the first thing that I'm going to do is establish a relationship between a fully saturated compound and the number of carbons and hydrogens that it has. So if we take, and we can do this with any structure that is just carbon and hydrogen, so any hydrocarbon, we see that each carbon has 2 hydrogens, on one on top, one on bottom, like this. So we have 2 hydrogens for this carbon, 2 hydrogens for this carbon, 2 hydrogens for this carbon, And then we also have these additional 2 hydrogens on either end. So 1 and 2. And so we can say that for a fully saturated hydrocarbon with n number of carbons, we can say that that fully saturated compound has 2n plus 2 hydrogens. The 2n comes from the hydrogens on top and bottom in this picture, and then the plus 2 comes from the ones on either end. So that's a relationship between the number of carbons and hydrogens in a fully saturated structure. So how is this useful? Well, now we know when we have units of unsaturation, because if we have any deviation from this 2n plus 2 number of hydrogens, we know that we have a unit of unsaturation. So how much space? Okay, so let's start with, let's say we have a compound that's C5H8. So normally a saturated carbon, so a saturated structure with 5 carbons should have 2n plus 2, that's 12, should have 12 hydrogens. Right? But we only have 8 in the structure, and that means we're missing 4 hydrogens. And so if we're missing 4 hydrogens, we know we have 2 units of unsaturation. So that's how it's useful. But this is a pretty gross oversimplification of this strategy, because we're not only going to be dealing with compounds with just carbon and just hydrogens. There's also going to be other elements present. So we have to incorporate that somehow. And okay, so let's start with the first one. Let's start with a halogen. So if we add a halogen to our structure, we're pretty much replacing 1 hydrogen. So our new formula looks like C3H7Cl, and pretty much the Cl acts like a hydrogen. So you can see how those 7 hydrogens, even though this structure fits the saturated, even though the structure is fully saturated, you can see that we have 1 less hydrogen than the 2n plus 2. So to alleviate that, we can count our halogens as a hydrogen. So we can be like, okay, well, we'll just add the number of halogens to the number of hydrogens, and we can satisfy that rule still. And that doesn't make so much sense right now, but it will later. Now let's look at oxygen. Now, since oxygen likes having 2 bonds, it actually brings along with it its own hydrogen. So we replace the hydrogen that was there with an oxygen plus another hydrogen. So actually, the number of hydrogens stays the same in our rule. We have C3H8O. So this fully saturated structure actually satisfies that rule, that our number of hydrogens are equal to 2n plus 2. And now let's look at nitrogen. I'll have to clear some space. So nitrogen actually brings along with it 2 hydrogens, since nitrogen likes having 3 bonds total. And so what this does is that it adds an extra hydrogen to our chemical formula. So now we have C3H9N, and this doesn't satisfy our little equation. So if we subtract, we can change that by subtracting the number of nitrogens from the number of hydrogens. So if we do 9 minus 1 nitrogen, we get 8, and that satisfies our equation. So I'm going to tell you how to use that. So let's say we have, oh god dang it, I'm going to scroll to the top. Let's say we have a structure C8 H12 O2 N3 Cl. Okay, so we're going to figure out how many units of unsaturation this structure should have. So what's our first step? Well, we have to determine how many hydrogens we should have when we have n number of carbons. So we have 8 carbons in the structure, right? And that means we should have 18 hydrogens. But we have to account for these other elements, right? So we know that our oxygens bring along as many hydrogens as they replace. So we don't have to factor that into account. So when we calculate our apparent number of hydrogens, let's say, we don't have to take our oxygen into account. So we do have 12 hydrogens. We don't have to add anything from the oxygens. Nitrogen brings along with it an additional hydrogen, so we have to subtract the number of nitrogens from our 12 H's, so minus 3. And then a chlorine replaces the hydrogen that it takes, so we have to add 1 for our halogen, so plus 1H, and that'll give us 10 hydrogens. So that's our apparent number of hydrogens from this structure. That's the number we're going to use to calculate our units of unsaturation. So if we calculate the number of hydrogens that we're missing, we get 18H. The number of apparent hydrogens we should have from a saturated structure, that's where we're getting our 18, minus 10, the number of apparent hydrogens we do have, and that'll give us 8 missing hydrogens. And so 8 missing hydrogens equals 4 units of unsaturation. And so what does that mean? Well, we know that means that our structure is going to have either a ring, a double bond, and a triple bond, or maybe it has 4 double bonds. Just some way all the double bonds, rings, and triple bonds add up to 4 units. I know that's not really helpful right now, but this tool will be of use in the future when you have a chemical formula. That's it for today, so thank you for listening. Hope this helped.